In this video we're going to look at integrals involving ln x. Let's start with the most basic example of such an integral, the integral of ln x dx. Once we know how to do this, we will be able to do many more complicated problems. We can compute this integral using the method of integration by parts. But of course, integration by parts can only be used when the integrand, that's the function we're integrating, is a product of two functions. At the moment, we just have ln x, so we must rewrite the integral as follows. The integral of ln x times 1 with respect to x. This is a perfectly valid thing to do, and though it may seem a bit pointless, it will allow us to use integration by parts to solve the integral. So, if we let u equal ln x, and v dash equal 1, then we have u dash is equal to 1 over x, and v is just equal to x. We're going to ignore the constant of integration for now. Recall that when integrating by parts, we have the integral of u times v dash dx, where u and v dash are functions of x, is equal to u times v minus the integral of u dash times v dx. If we substitute what we have for u, v, u dash and v dash in this example, then we get that the integral of ln x times 1 with respect to x is equal to ln x times x minus the integral of 1 over x times x with respect to x, which is equal to x times ln x minus the integral of 1 with respect to x, since the x's here cancel. That leaves us with x times ln x minus x plus some constant of integration, which we put in now that we've finished the integrating. So let's restate that result here to make things clear. We have that the integral of ln x dx is equal to x ln x minus x plus c. Now, let's try a second example. We're asked to integrate 2 times ln 3x with respect to x. Well, the first thing we have to do is make a substitution. So we'll let u equal 3x in this example. Then, du by dx is equal to 3, which implies that 1/3 times du is equal to dx. That's multiplying both sides by dx and dividing both sides by 3. So we can rewrite our original integral like this. The integral of 2 times ln 3x dx is equal to 2 times the integral of ln 3x dx. Because 2 is a constant, we can just take it outside the integration. And now we make our substitution, and we get 2 times the integral of ln u times 1/3 du. Again, we've got another constant here, so we take that outside to get 2/3 times the integral of ln u with respect to u. And at this point, we can use the identity to say that 2/3 times the integral of ln u with respect to u is equal to 2/3 times u times ln u minus u plus some constant of integration, which is 2/3 times u ln u minus 2/3 u plus 2/3 times c. And now we're going to substitute back to get an expression in terms of x. So we get 2/3 times 3x ln 3x minus 2/3 times 3x plus 2/3 times c. 2/3 plus c is just another constant, which we'll call d. The 3's cancel, and we're left with 2x ln 3x minus 2x plus d.